Hello, my name is Professor TK the Chemist, and today I'm going to give you all an example of how to work limiting reactant problems. As you can see on the screen, there is a problem here that is going to have you guys solve for the limiting reactant. And if that sounds simple enough, take a look and stay tuned at how simple this process is going to be. Are you ready? I'm ready. Let's get into it. In case you're wondering what is a limiting reactant means, it means simply this. Which one of these reactants is going to prevent the product from being produced fully? The one that provides the smallest amount is the limiting reactant. So for instance, when we calculate our problem here and we discover that between iron 2 oxide and aluminum, if one of those items produces the limited amount or the smallest amount of product, that's going to be your limiting reactant. Let's go ahead and establish what we need to do. First step, make sure this reaction is balanced. As you can see, the reaction is balanced. So now move on to step number 2. Note what is given in the problem. In this particular case, let's read it. A 1.00 mole sample of iron 2 oxide is heated with 1.00 moles of aluminum metal and converted to molten iron. Identify the limiting reactant and calculate the moles of iron produced. Let's do a correction that says heated and we meant heated. Okay? It's been corrected. So now, in this problem, they've given us two things. Number one, they've established that we have 1.00 moles of iron 2 oxide, and we also have 1.00 moles of aluminum metal. What we have to do is calculate the limiting reactant based on the moles of iron that's produced. So here's what we're going to do. We're going to first take our first number here, the 1.00 moles of iron 2 oxide, and we're going to convert that to the moles of iron that's producing. We also need to look at the coefficients here. That means the number that's in front of each of these compounds and elements in order to establish what our limiting reactant is going to be. So here's the first one that I'm going to do. 1.00 moles of iron 2 oxide times. Now right here, this particular step, we're going to put on top 3 moles of iron. On the very bottom, 3 moles of iron 2 oxide. Again, we get the coefficients from this number here and this number as well. Next, we're going to multiply 1.00 moles times 3 divided by 3, and that's going to give us our answer. Now, here's something else you want to do. Cancel out your moles of iron 2 oxide because we no longer need that number, and we're going to write out 1.00 moles of iron as our first answer. Now we need to look at the second one. We were also given 1.00 moles of aluminum metal. So what are we going to do? We're going to convert that to the moles of iron. So that's why I'm putting that number on the very top. 3 moles of iron is on the top, and go back to my coefficient now for aluminum and put 2 moles of aluminum on the very bottom. We're going to cancel out moles of aluminum, and now we're going to multiply 1 times 3 divided by 2, and you get 1.50 moles of iron. Now from this picture here, from what you see, which one of these elements actually provided the smallest amount of product? If we take a look, we have 1.00 moles of iron and 1.50 moles of iron. The limiting reactant is the number that was the smallest. So therefore, we know that the 1.00 moles of iron 2 oxide is the limiting reactant. If you need another example like this, stay tuned and we've got you covered. If you have questions about this, make sure you put a comment in the chat box below and we'll get back to you. I hope this answered your question about limiting reactants. Stay tuned because I may have another example for you. Okay? Take care and good luck on your final exam.